Hello, second grade scientists. Miss Hutchinson here in my backyard for more Science Lab. I hope by this point you've watched all of the exploration videos on Mystery Science and learned all about why so many toys are made out of plastic. Being meltable makes plastic such a great material so that many toys can be produced at one time and it isn't too expensive. However, our problem today is figuring out what candy would be best to send to a friend in the summer heat. Being meltable is great, but when it comes to candy, you don't want it to melt before it gets to your mouth. So we have to figure out what candy can survive a trip in the heat to get to our friend this summer. So for today's activity, I'm going to test 4 different kinds of candy to figure out which would be best to send to a friend. First, I want to review the materials that you're going to need if you're going to try this at home along with me. The materials to try the candy melt are as follows: a container of warm to hot water, hot to the touch but not scalding, 4 different candy options. Candy 1, something like chocolate chips or chocolate rectangles. Candy 2, something like Starburst, Skittles, caramel, or butterscotch chips. Candy 3, something like Swedish Fish, jelly beans, Jolly Ranchers, or gumdrops. And Candy 4, gummy worms or gummy bears. You will need a plastic bag for each candy you plan to test, and something like a popsicle stick, spoon, or other utensil that will help you keep each bag underwater. Lastly, you will need a timer set for 2 minutes. Now that we've gone over our materials, let me show you what I chose to use for my candies today. I have some chocolate. I have a Hershey's bar. I'm going to use a little bit of pieces of it, a few pieces of it. I have Swedish Fish. I've got some gummy worms, and I've got a package of Starburst. So those are the 4 candies I will be testing: chocolate, Swedish Fish, gummy worms, and Starburst. I've also got baggies ready to go, a container, and hot water off to the side ready and waiting. Now before we get started doing the activity, let's review the steps in case you want to try it at home on your own. Here are the steps to take if you want to try it at home on your own. First, gather all of your materials. You can test 1 candy type or all 4. Just use what you have at home. Second, put a few pieces of candy 1 into a plastic bag. Do the same for each type of candy you want to test. It's really important to try to make the amount of candy in each bag equal. Third, make sure your timer is ready and set for 2 minutes. Fourth, place all the bags of candy into the container with hot water. Use a utensil to keep the candy under the water for 2 minutes. Fifth, when the 2 minutes are up, pull the bags out of the water and use the Mystery Science worksheet to answer questions and take observations. Now that we've reviewed our steps, we're actually ready to get started. The first thing I want to do is make a prediction. Which candy do you think will be best to send to a friend in the summer heat? And best probably means which candy won't melt in transit. Do you think chocolate, gummy worms, Swedish Fish, or Starburst? It's an interesting prediction. Why do you think that? Tell a family member why you chose that candy. Do you want to hear my prediction? I think gummy worms would be the best candy to send a friend this summer. They're bigger, so I think that makes it take longer for them to melt. Plus, they're just so silly and fun to eat. All right, now that we have our prediction all set up, let's get started. All right, we're now ready to get started. I have my container of hot water. I think you might be able to see the steam. I've got some chocolate in a bag, some Swedish Fish in a bag, a couple of gummy worms, in a bag, and some Starburst in a bag. I've also got some popsicle sticks to help me keep everything underneath the water. My phone's right here ready with a 2-minute timer. So I'm gonna put the bags in, make sure they're all underwater, and turn on a 2-minute timer. Let's see what happens. Starburst, gummy worms, Swedish Fish, and chocolate. All right, everything's underwater. 2-minute timer is on. So, do you think all of the candies will melt? I don't know. What do you think? Why do you think that? I think they all might melt a little bit, maybe not completely. I don't know. If you use the mystery science worksheet, it asks some questions, and I can't print it at home, so I'm not using that exact worksheet, but I made a similar one on my own. So I will be looking at when we take the candy out, does the shape of the candy change just from the heat of the water? That's the first thing we're gonna look at when our timer goes off. Then we wanna feel it. Can I squish it? When I squish it, does it change its shape? That's another important thing. Maybe it doesn't change on its own, but once you feel it, you can tell that it can actually change and squish its shape. Then we're going to take a moment and draw a picture of what they all look like after we kind of squish each candy. And the last thing is to decide whether it's a totally solid still, whether it's kind of partially melted, which means you can squish it and kind of change it, or if it really has changed to a liquid. So as our candy continues to sit underneath the hot water for another, let's see, another 45 seconds, you can take your final predictions and decide what you think is going to happen. I can't tell anything yet, but it's still got a little bit more time, and we'll see what happens when we take it out. Again, we're looking to see, does it change shape with just the heat of the water? When I squish it, does it change its shape, or does it kind of stay the same? And what would I describe it as? Would I describe it as totally solid, totally melted, or partially, somewhere in between? I have some guesses, but I'm excited to see what happens. I've never melted so many different types of candy at the same time. But with summer coming up, it's good to know. And there goes my 2-minute timer. So let me turn that off. I've got a tray here that I can put my candies on, and let's see what happens. All right, I'll take out my chocolate first. What do you think? Did it change its shape? Oh, as I shake the bag, is it changing its shape? It sure is. How about when I squish it? Whoa. When I squish it, it's totally moving around completely differently, huh? What do you think? If you had to decide between totally solid, partially melted, or now a liquid, what do you think? I'm going to say that is completely melted. Check out that chocolate. Ugh. All right, we'll record our data after I get through these other candies. Let me see. Next I have, let's check our Swedish fish. Did they change shape just from the heat of the water? Doesn't look like it. How about if I squish? Even when I squish, they keep their shape and they feel pretty firm. What do you think? Totally solid, partially melted, or completely melted? I'm going to say, based on how they feel and how they're not changing shape when I squish, that they are totally solid. How about my gummy worms? Let's take a look at those. Just the heat of the water doesn't seem to have changed their shape very much. They still look like worms. Let's see what happens when I squish. Whoa! When I squish, can I change their shape? Yeah, I can totally change their shape. They don't look like worms so much anymore, huh? That means we have to decide totally solid, partially melted, or completely melted. They're not a liquid. They're not going to run around in the bag, but they're definitely not a solid. So let's call them partially melted. I think that's fair. That just leaves our starburst. The heat of the water alone didn't change their shape. They're still in that same square shape, but let's see what happens when I squish. Oh, I can definitely change their shape when I squish them. But they're not quite as squishy as the gummy worms. So if I had to say if they were solid, totally melted, or partially melted, these two are partially melted. Gummy worms are more melted, but these are partially melted as well. All right, I'm going to pause for a moment so I can take down my data, and you can do the same if you're using a worksheet at home, and then let's look at our results. Here's the data sheet I made based off of the mystery science one I couldn't print at home. I started with my question, what candy is best to send a friend in the summer heat? We did a prediction together. My prediction was I think gummy worms are best to send because they are bigger than the other candies and I think it will take them longer to melt. Also, they look like worms. We did our experiment and we collected data together. You can see I looked at whether the candy lost its shape, does it change when I squished it, and made a decision as to whether each candy was totally solid, partially melted, or melted to a liquid, or pretty close to it. Our chocolate was the only one melted to a liquid, while our starburst and gummy worms were partially melted and our Swedish fish stayed totally solid. Based on all of our data, I would have to say the best candy to send a friend in the summer heat are the Swedish fish. They didn't change at all. Now that we've had time to review our data, let's check our prediction. I predicted gummy worms would be the best candy to send in the summer heat because their shape would make it take longer for them to melt. Is that what we found in our experiment? It wasn't, was it? In fact, our gummy worms were probably one of the worst candies to send. Chocolate would be worse, but not much worse than gummy worms. What about your prediction? Was your prediction correct? Nice. Maybe you kind of figured Swedish fish would be the ones to take the longest to melt. Well, now that we've looked at different candies and how quickly they may melt, do you think if we had the equipment, we could put our candy back to the way it was before we put it in the hot water? Could I change that melted chocolate back into a chocolate bar? What do you think? Yeah, I really could. I could take that melted chocolate, put it in a mold, let it cool, and it would turn back into a chocolate bar. In fact, all of our candies, given the right resources, we could turn back into the candy it was before we put it in the hot water. That means our experiment today showed a physical change, or a change that can be reversed. Our candy didn't change the way it's made, it just changed its shape and its state. It went from a solid to a more liquid form, but if we put it in a mold and let it cool, it would go. Now, what about if I had put a raw egg in its shell into that hot water and let it sit there for a while and let it cook? Do you think if I cracked open that egg, it would look the same as if I had never put it into the hot water? No, it would have been boiled in some way, shape, or form. If you see a hard-boiled egg, you can see that it looks different than a raw egg. Now, if I had let the egg actually boil all the way through, do you think I would then be able to reverse that change, put it back to the egg it was before putting it in the hot water? What do you think? No, right? Once that egg is cooked or hard-boiled, I can't turn it back into the egg it was before. So that means that the egg underwent a chemical change, or a change that is not reversible. When you cook food, most of the time, that's a chemical change. You can't take it apart and put it back how it was. So what it all comes down to is that heat can cause two different types of changes in a material. A physical change that can be reversed, and a chemical change, which really can't be. It is not reversible. We saw physical changes in our candy melt today, and you see chemical changes when you cook food at home. That's all I've got for you today. Until next time, little scientists, stay curious.